Right. So we have some serious questions out here to discuss in the fast track question tute number 1. Right. So first one, a child runs in a straight road with a speed of 4 meters per second for 10 minutes, and since he was tired, he walked with 1 meter per second speed for 5 minutes. Find the average velocity in meter per second. So you know, average velocity is the total displacement divided by the total time. So this question is, I'll categorize it as easy, right? So how to do this? Child runs in a straight road with a speed of 4 meters per second for 10 minutes. So initially displacement, okay, we are calculating the total displacement, right? Total displacement, initially how much? 4 meters per second multiplied by time, you are going to get displacement S equal ut, okay, S equal ut. Then 4 meters per second into 4 into 10 minutes, okay, so 10 minutes you need to convert it into seconds, so 10 into 60 plus, then after that he was tired and then he walked with 1 meter per second for 5 minutes, right? So 1 meter per second for 5 minutes, 5 into 60, right? So 5 into 60, so it's going to be 6 into 4, 24, 2400, and 5 into 6, 30, 300. Am I correct? 6 into 4, 24, right? So it's going to be 2700, right? 2700 meters total displacement. And the total time, obviously 10 plus 15, and it's going to be, total time is going to be 10 into, what you call 10 into 60 plus 5 into 60, easy, right? So how much? 600 seconds plus 300 seconds, 900 seconds. So 900 seconds. The average velocity is going to be equal to, average velocity is going to be equal to total displacement divided by total time, 9 into 3. So 3 meters per second. Answer number 3, right? So answer number 3. You can pause the video now. This is going to be a recording, right? You can pause the video if you want and just write it out. Then the second question, what did they say there? In the above question, before if he started to walk after taking a 5-minute break. So he's running, then he will stop for 5 minutes and then he will again start to walk. Okay, before he walks, he start taking a 5-minute rest. So like he's running and resting, standing in one position for 5 minutes and then again starting to walk. So same displacement, actually, so the same displacement is going to be, but this total time is going to be affected, right? Total time is going to be affected. He is going to rest, take a break of 5 minutes, right? So 5 into 60, you need to add it again. That means plus 300. That means 1200 seconds. It doesn't matter anything else. It's just average velocity is equal to total displacement divided by total time. Never forget that. Okay, total displacement divided by total time. So it's going to be 2700 divided by 1200, and it's going to be 3 into 9, 3 into 4, right? So 2.25, I guess, right? 2.25. Is that an answer? Yes, 2.25 meters per second. Second question, 2.25 meters per second. Then third question. Okay, what do they say there? A motor car travels with a speed of 60 kilometers per hour half of the journey and the remaining half with 40 kilometers per hour. What is the average velocity of the total journey? Now some of you might have added 60 and 40 and divided by 2. You are absolutely wrong. Okay. So how to do this question? Always you need to follow this procedure. I mean, average velocity is equal to total displacement divided by total time, right? Total displacement divided by total time. Never forget that. It's going to be total displacement divided by total time. So how to do this question? So first, let's take the motor car traveling 60 kilometers per hour, half the journey. Now I'm going to mark this journey. From here to here is the total journey. So half the journey means up to here, right? Half the journey means up to here. From here to here, he's going to move with how much? 60 kilometers per hour. From here to here, 60 kilometers per hour, right? Then from here to here, he's going to move with 40 kilometers per hour, right? 40 kilometers per hour after that. What is the average velocity for the total journey in kilometers per hour? What is the average velocity? Right. First, what is the information they have given? What is the information they have given? They have given the speed, okay, 60 kilometers per hour from here to here and 40 kilometers per hour from here to here. What else do you know? And then you know that this displacement is equal to this displacement. Why? They say half of the journey. So if the total journey is this one, you divide that by exactly half. This one is going to be equal to that one. Okay. So that one, no need actually. No need that one. Yes, you need that one. So this is S. I'll take it as S. I'll take this one as S. Okay. So here S is going to be equal to. So let's take from moving from here to here, you take time t1. Right, moving from here to here, you take time t1. Then you can write S is equal to ut, right? S equal ut. There's no acceleration there, so S equal ut means S is going to be equal to what's the? I'll just take it in kilometers per hour because the answers are there in kilometers per hour, right? So no need to convert into meter per second. Just waste of time. Okay. So 60 times t1, and t1 is going to be in hours. Okay. How do you see that? This is kilometers per hour multiplied by t1, which is in hours. You are going to get kilometers, which is a displacement, right? So this is going to be the first equation. Then after that, from here to here, that one also going to be S. So S is going to be equal to 40 times t2. I'll take this one as t2. Okay, time taken is there t2. So you can see 1 and 2 is going to be equal. 60 t1 is going to be equal to 40 t2. 0, 0 cancel, 2, 3. So 3 t1 is equal to 2 t2. You can subject anything you want. I'll just subject I'll subject t2. t2 is going to be equal to 3 t1 divided by 2. t2 is going to be 3 t1 divided by 2. Then after that what? After that, what you're going to do is you're going to make a relationship for average velocity. So average velocity means what? Average velocity is going to be equal to total displacement divided by total time, right? So total displacement going to be 60 t1 plus 40 t1. 60 t1 plus 40 t1 divided by the total time t1 plus t2. Okay, t1 plus t2. This one will be t2. Now you can't cut t1 plus t2 with this one, right? Like that. It's not maths. Okay. If you do like that, you need to go to grade. What do you call grade 10? I think. Yes, grade 10. Grade 10 or 8 also you do some things like that. So these kind of mistakes, just mathematics, okay? Don't do such kind of stupid mistakes. So 60 t1, you found a relationship for t2 and you are going to substitute this one into here. So 60 t1 plus 40 into what is t2? 3 t1 over 2 divided by t1 plus 3 t1 over 2. Nice. Then what will happen? 2, 4. It's going to be 20 up here. Then 3 into 2, 6. So 60 t1 plus 60 t1, 120 t1. And you're going to take a common denominator here. It's going to be 5 t1 divided by 2. And then after that, you're going to take this upside down. 120 t1 into 2 divided by 5t1. T1 cancel off. Then easily you can get an answer. 5 times 2, 10 to remain 5 times 4, 20, and it's going to be 48. Is there an answer like that? Yes, there is an answer. Answer number 2, right? 48, what do they call it? Kilometers per hour. This is going to be kilometers per hour. Good, right? Write this down. Stop the video and write this down. Now, I can't give you time to write. You can stop the video. Okay. Then there are two questions which have problems. The last question, question number 20, is repeated. I didn't notice that until last. So that question you don't have to do it again. And also question number 11, there is a printing mistake there, and information is missing in there. So leave that question also, right? You can find the answer for that. Now question number 4. An object started traveling from rest, moves at a uniform acceleration of 2 meters per square second. Okay, correct that, 2 meters per square second. What is the time taken and the distance traveled to achieve a speed of 36 kilometers per hour? Now there you need to convert 36 kilometers per hour into meter per second. That one is the first thing you should do. Okay, that one is the first thing you should do. 36 kilometers per hour, you're going to convert to meter per second, right? So 36 kilo means 1000, right? Multiplied by 1000, and per hour means like hour will go behind. I mean, behind bottom, right? So you need to convert hours into seconds. So how to convert hours into seconds? 1 hour is 60 minutes. 1 minute is 60 seconds. So 60 times 60. So what you can actually do is multiply this by 5 over 18. That is the easy method. You just see 36 kilometers per hour. Next time you're just going to multiply it by 5 over 18. So directly you can get an answer 5 into 10. But this is the first time, so you should do it like this. Then 0, 0 cancel off. Then 5. This is 3. 16, 3, 18. Right? So 18 to 10 meter per second. Right? 10 meter per second. So what do you have to find now? What is the time taken and the distance traveled to achieve a speed of 36 kilometers per hour? Right, object starting at rest. So what are you going to find? The time taken. V equal U plus AT. Can you apply that? Can we apply that? What have they given? Acceleration given. Time given. No, time only we have to find. Then time we have to find, and the distance also they are saying we have to find. Okay, we can apply V equal U plus AT. V equal U plus AT. Final velocity 10 meters per second. Initial velocity how much? Starting from rest. Yes, starting from rest 0. Don't mind the sounds. Okay. So A is going to be how much? 2 meters per square second into time. Easy. E is going to be 5 seconds. Voila. Good. Then after that, the distance travel you can find S equal ut plus half AT square or whatever you can apply. S equal ut plus half AT square, initial velocity 0, then half into 2 into 5 into 5, 25 meters. Direct answers, easy questions. Then question number 5. Question number 5. The liftoff velocity of a plane is 50 meters per second. If the runway is 500 meters, what is the acceleration in which the plane should move to lift off? So the runway is 500 meters. So you know the displacement made should be 500 meters. Then after that, the liftoff velocity, that means the final velocity should be 50 meters per second. For every plane, when you're going like this, there is a certain final velocity which will give the lift to the plane. You will learn this under burn only. I mean, the up thrust getting from this Bernoulli principle only, they are obtaining this upthrust. Once you go fast enough, the air currents will push the plane upward. So that is what lift the plane. Once the upward force overtakes mg, that is when the plane lifts off. So that should have a certain velocity. So this velocity, they have just set it 50 meter per second. Right? So, and the distance is going to be 500 meters. They are asking what is the acceleration in which the plane should move to lift off. So, you know, initial velocity is going to be 0. So, final velocity is going to be 50. Then acceleration only asking and the displacement is given. So, what you are going to use? V squared equals u squared plus 2s. Final velocity 50 squared. Initial velocity is 0 plus 2 into a into what is this 500, right? So a is going to be equal to 50 into 50 divided by 500 into 2. 0 0 0 0 5 5 1 5 over 2 2.5. Am I correct? Yes, am I correct? Okay, good. 2.5 meter per square second. Then sixth question. Sixth question, these are very easy questions. The first few questions are very easy. Boat traveling at an acceleration of half meter per square second gains a velocity of 50 meter per second after traveling a distance of 2.1 kilometers. What is the initial velocity and the time taken to travel this distance? Easy question. Just apply the equation. You can get an answer. Right. Then boat traveling at an acceleration of half meter per square second gains a velocity of 50 meter per second after traveling a distance of blah blah blah. What is the initial velocity and the time taken? V equal u plus v squared equal u squared plus 2as. V squared equal u squared plus 2as. Final velocity is going to be how much? 50 squared. Right? So 50 squared. And the initial velocity, they are asking what is the initial velocity. And what else? Plus 2 into acceleration half into distance is going to be 2.1 into 1000, so meters. Then what do you have? U is going to be equal to 5 into 5, 25, 2500 minus 2100, right? 1, 2, 3. So u squared. U squared is going to be equal to 400. U is going to be equal to 20 meter per second. And the time taken, V equal U plus 80. V equal U plus 80. Final velocity is going to be 50 is equal to 20 plus half into t. So t is going to be 60, right? Yes, 60 seconds. 60 seconds means 1 minute. So answer is going to be answer number 5. Right? Answer is going to be answer number 5. Question number 7. Which of the following is not a graph corresponding to an object moving at positive acceleration? Okay, now accelerating object. Accelerating object, you have learned this. Like ST graph will show something like this if it is accelerating. Velocity time graph will show something like this if it's accelerating. Only those two only we have learned until now. You can see the first graph. What is that? The gradient of the ST graph is representing velocity, and the velocity is going to be uniform. So the gradient doesn't change, the velocity doesn't change. Then A doesn't show. So A doesn't show. Then B is going to show acceleration. Agree with me here, right? So it is going to show acceleration. Then third one, velocity time graph. The velocity is going to increase. C also shows, right? C also going to show. And fourth one, velocity time graph. Okay, now velocity time graph is showing something like this. Means what is the meaning of that? If the velocity time graph is showing something like this, what is the meaning of that? So in the velocity time graph, if it's increasing like this, The gradient of the velocity time curve represents what? Acceleration. So it is already representing an acceleration, and the acceleration is going to increase. So this type of graphs are out of the syllabus, but you need to understand what is there in it. I mean, the gradient is increasing. So the acceleration is going to keep on increasing. I hope you get that. Do not forget to see the axis, okay? This is velocity time graph. You are going like this. So V is going to show acceleration, and the acceleration is changing also. So the answer is only A, right? So answer is going to be answer number 1. Answer is going to be answer number 1. Okay, then next one. A particle projected vertically upward at a velocity of 40. This is a nice question. If you understand the equations of motion so well, you can just directly take an answer for this. Like if you understand vectors and if you like apply equations with so much understanding, you can get this answer very easily. So particle projected vertically upward at velocity 40 meters per second. So what will happen? This object will go up, then come down, right? It will come down and hit the ground. Right? Go up, come down and hit the ground. So here upward 40 meters per second. And the acceleration is acting downwards, right? So mg is acting downwards. Gravitational acceleration is acting downwards. Then from the top of the tower hits the ground after 10 seconds. So time is going to be 10 seconds. It will go up, then come down. So what is the displacement of this? So the displacement, no matter wherever it goes, finally it's going to be the initial position and the final position. It's going to be h. Right? It's going to be h. Then you are applying s equal ut plus half at square, and you are getting a direct answer for this. Okay? You are getting a direct answer for this. How? S equal ut plus half at squared. You need to indicate the direction you are applying. Okay? You need to indicate the direction you are applying. Always remember, if you apply to downwards, right? So downward displacement from here to here, positive, h. Initial velocity. You have marked this to the top, right? So the guy is pushing the ball to the top. So it's going to be minus 40 because we are applying the equation downwards and they are vectors. Do not forget that. Okay, they are vectors. So minus 40 multiplied by time. Time is 10. Right? So acceleration downwards, I am applying the equation, so it's going to be positive. Plus half into 10 into 10 into 10. So 10 squared. So it's going to be how much? It's going to be 5. So 50, 500 minus 400. So 100 meters. Sit. 100 meters. 100 meters, answer number 2. Right? Answer number 2. Then next one. 9th one. And this is a tricky question. This is a hard question. I'll tell you this is hard. 9th one is going to be hard. I bet only one person or two people have done this. Maybe none of you have done. So, 9th one. Two objects. This is relative motion. Relative motion, one of the complex questions they can ask. If you know what is relative motion, if you know the basics so well, this question is going to be easy for you. And if it's hard for you, you should understand from today this question pattern. There's a past paper question just altered. Okay, past paper question is there same like this, but just altered a little bit. So what do they say? Two objects x and y. Okay, x and y are there. Two objects x and y. Okay, this one is x, this one is going to be y. What do they say? Separated by 5 meters each second. So 5 meters each second means meter per second. So velocity they are telling. Okay, the distance between them is going to increase the distance between them is going to increase by 5 meters every second. So 5 meter per second, their distance between them, the gap between them increases. So you need to understand that what they are telling is relative motion. Velocity of x with respect to y is going to be 5 meter per second. Or you can say velocity of y with respect to x is going to be 5 meter per second. Either way you can take. But what they are telling is the gap is increasing means it's like not the velocity of one person, but the velocity of both the people. And both are moving to the opposite direction. So they get separated. Okay. So they are moving in opposite direction, right? Yes. One is moving this direction, other one moving in this direction. Then next one, what do they say? Approach 1 meter in each second when they are moving in the same direction. Okay, now what? X and Y are there and they are moving in the same direction now, and they are same direction means this one, this side, same direction, so same direction they are moving. So when they move like this, they are getting closer. So this one getting apart. This one getting closer 1 meter every second. So 1 meter per second. Okay. Right. Now carefully listen. Right. Carefully listen this. Carefully listen. Velocity of x with respect to, I will write this relationship. Velocity of x with respect to y in this situation, okay, is going to be equal to velocity of x with respect to earth plus velocity of earth with respect to y. Mark the directions. So x with respect to earth is going to be this direction, and earth with respect to y is going to be again this direction. We have done these things, okay? Right, now what? Now you know the velocity of x with respect to y is going to be 5. Why? The gap is increasing. So just think in your head. I mean, just imagine it. Both the people are moving, then what happened to the gap? Gap is going to tell you the relative velocity. You mean this question pattern, you need to understand if they say about the gap, it's relative velocity they are telling. Velocity of one person with respect to the other, not the earth. Okay, not the earth. Then velocity of x with respect to earth, I will tell it as x, simple x, right? And this one I will take it as y. So it will make it simpler, right? So x and y. I'll take it as x and y. So velocity of x with respect to earth is going to be x in this direction. Velocity of earth with respect to y, if this one is going to be that side, then it's going to be y here, right? It's going to be y in this direction, right? It's going to be y in this direction. That's the first equation we can get. So the second equation we can get, v is velocity of x with respect to y, right? So velocity of x with respect to y is going to be equal to velocity of x with respect to earth plus velocity of earth with respect to y. Then velocity of x with respect to earth, x with respect to y, 1 meter per second. 1 meter per second. Always consider directions, okay? These are vectors. Always mark the directions and keep it like that. It's going to be useful later. So 1 meter per second, velocity of x with respect to earth here in this direction, x. And velocity of earth with respect to y, if y is moving that direction, earth should be moving in this direction, right? So that's going to be y in this direction. So you know vectors in same direction, you can't deal with it, right? So you bring both the vectors to one direction. So either you can put x minus y, and when you add these two equations, you're just like, you have to again convert. Okay. So what I'm going to do is, I'm going to bring this x to one direction. Y minus x. So when you change the sign, you change the direction. Don't forget that. So 1 is going to be equal to y minus x. So this is equation number 2. This is equation number 1. This is equation number 1. So in case like, if I told like, if you did like this, 1 is equal to x minus y, and you took the both the vectors like this, and then if you go on and add them, you're wrong. Why? These vectors are to the right, these vectors are to the left. You can't add vectors which are in opposite directions. So if you are like, you're going to convert this, You are going to add this one into that one. You are going to multiply this by minus 1 both sides. So minus 1 is going to be y minus x. So like something like this you are going to do. Okay, y minus x, but in this direction. Right, you are going to change the sign. But here no problem like that. Right, no problem like that. You are going to directly take it. Y minus x. Good. Now what? Now you are going to, you can see, you can add them together, right? So 1 plus 2, you are going to get 5 plus 1 is going to be equal to x plus y minus x, right? So 2y is going to be 6, y is going to be 3. So y is going to be 3 means x is going to be 2, right? Y is going to be 3, x is going to be 2. Why? X plus y 5. So x is going to be x plus 3 is going to be 5. Then x is equal to 2. That's it. Answer number. What do you have? Answer? X and y. X is going to be 2 and y is going to be 3. 2, 3. 2, 3. Or 3, 2. What are you finding? 2, 3, right? Am I correct? Did I make anything mistake? Answer 4. Yes. Wait a minute. Did I do anything wrong? Is there a mistake here? Vxe, correct. Then velocity of x with respect to y, there, and x minus y. Okay. Wait a minute. X plus y. Yes, I have made the mistake here. What have I done? First, you need to like convert that velocity of x with respect to y is going to be how much? 1 meter per second. So 1 is going to be equal to velocity of x with respect to. So that's why I say you be careful when you are dealing with vectors. Okay. So arrows very important, signs very important, plus minus very important. You are going to mess up your answer. That's right. So I messed up. So you don't mess up, right? So velocity of x with respect to Earth, this one, x in that direction, x in that direction. Plus, you can see Earth with respect to y, you are going to like turn it around. Okay, like I'll write it like this: velocity of x with respect to Earth minus velocity of y with respect to Earth. You're going to like flip it up, right? When you're flipping, you change the sign also. So velocity of x with respect to Earth, x in that direction, minus y in what do you call that direction? Then 1. So you can see I said you when you are adding two vectors, they can't be in the same direction. So what do? You make them like this. So you multiply by minus 1. Minus 1 is going to be equal to minus x plus y. So minus 1 is going to be equal to y minus x. And now you can add them. So now you can add them. 1 plus 2. So 5 minus 1 is going to be equal to x plus y minus x. 2y is going to be equal to 4, y is going to be equal to 2, then x is going to be equal to 3. That's it. Answer number 4. Yeah, you see that? The mistake there. What did I do? I just put y for this term, but y is not that. Okay, if I am putting y there, I should put minus y in the beginning itself. I didn't put like that. So be careful with the directions and signs. Okay. Then question number 10. That one is going to be easy, and there is a printing mistake there also. So these are school paper questions. Question number 10. Object starts its motion at rest and moving under uniform acceleration. Okay, I will draw this one. So there, what's going to happen? Object starts its motion at rest, moving under uniform acceleration in time t1. Okay, first uniform acceleration, displacement time graph they're asking, right? Displacement time graph, t graph. Uniform acceleration is going to increase its velocity like this, right? The gradient is increasing. Then after that it says it's going to move with uniform velocity. Again, it's going to move with uniform velocity. So it's going to not change any, there won't be any curves here. It's going to be a straight line. It's going to be a straight line there. Then after that, then it returns back to its initial position after deceleration. Alright, okay. Now you can see the displacement time graph, 0, right? So you need to come back to 0. So when you're coming back to 0, they are deaccelerating. So the gradient is going to be reduced. So it's going to be something like this. So you can directly take an answer for this. Right? So it's going to be answer number 5. It's answer number 5, but there's a problem there. The acceleration time graph. First you have acceleration. Okay, first you have acceleration. So positive acceleration. After that, you are going to have negative acceleration like this. So this one is going to be the answer actually. So there's a printing mistake. Answer number 5. Then question number 11, skip that. That's the problem. Then question number 12 and 20 are like same, I think. Yeah, they are same. Let's do that. Then a car accelerates from rest at constant rate alpha for some times, after which it deaccelerates at constant rate b and comes to rest. If the total time elapsed is t, then the maximum velocity obtained. Okay, now how to do this? You have an object. This is Vmax. You accelerate until Vmax. Okay, you accelerate until Vmax. What's the time taken? Let's take it this one as t1, this one as t2. Okay, then constant rate alpha. So acceleration is going to be alpha. Here deceleration is going to be beta. So minus beta. So acceleration is going to be minus beta. Then total time t1 plus t2 is equal to t. What else? What else we can take? This one is going to be at rest. Right. Now what they are asking to find? Total time elasticity, final, the maximum velocity. Okay. How to find the maximum velocity now? Okay, first you can apply v equal u plus at for this motion, and then you can apply v equal u plus at for this motion. So from this position, you can apply v is equal to u plus at. V max is going to be equal to, initially starting from rest, right? Yes, accelerates from rest. So 0 plus alpha in a means alpha. So a is equal to alpha. A is equal to alpha into t1. This is equation number 1. Then next one, V max is going to be equal to initial velocity is going to be sorry. You apply V equal u plus at. You apply V equal u plus at for this scenario. Final velocity is going to be 0. Initial velocity is going to be V max. And the acceleration is going to be minus beta t2, right? Minus beta t2. So beta t2 is going to be equal to V max. Now you have two equations. You can substitute to here. So t1 is going to be V max over alpha. Okay, t1 is going to be V max over alpha. T1 is going to be V max over alpha. Then t2 is going to be V max over beta. V max over beta. So plus V max over beta is going to be is equal to t. You can make common denominator. V max beta divided by alpha beta is plus V max alpha divided by alpha beta is going to be is equal to t. So V max you take out and you have beta plus alpha divided by alpha beta is equal to t. So V max is going to be equal to t alpha beta divided by beta plus alpha. That's the answer. Answer number 2. Answer number 2. Then question number 13. Question number 13. A car moving with uniform deceleration reduces its velocity from 30 meter per second to 15 meter per second within 10 seconds. Okay. 30 meter per second, 15 meter per second in 10 seconds. Okay, we need to find the deceleration now. V equal U plus AT. Right? V equal U plus AT. What is the final velocity? 15. Initial velocity 30 plus A into time 10. So it's going to be A is equal to 1.5 meter per square second minus, right? Minus 1.5 meter per square second. Then what else? Then we should find after how much time does the car come to rest. Again, you should apply V equal U plus AT. Now the final velocity is going to be 0 because it's coming to rest. So here U is going to be same 30. Okay, then minus 1.5. You found this, you are going to apply this here. Into time, you are going to find now. 1.5 T is going to be equal to 30. So T is going to be equal to 300 divided by 15 is going to be 20 seconds. So that one answer is going to be 5th one. Then 14th one. An object starting from rest accelerates uniformly. Okay, object starting from rest accelerates uniformly. What is there now? Object starting from rest accelerates uniformly. In the 5th second, it travels a distance of 90 meters. What is the velocity of the object in the end of 5th second in meter per second? I taught you an equation. You can use that if you want. Sn is equal to u plus a over 2 into 2n minus 1. So initial velocity is going to be starting from rest. So no problem, 0. Plus acceleration, we are going to find it. Right? We are going to find the acceleration a and the 5th second. So a over 2 into 5 minus 1, right? So a over 2 into 5 into 2, take 5th second, right? What is the velocity at the end of the 5th second? So 5th second. So a over 2 into that's going to be 5a, right? 5a minus a over 2. So that's going to be 9a over 2. Am I correct? Sn is equal to 9a over 2. Sn is going to be equal to 90. So 9 and 9 cancel. A is going to be equal to 20 meter per square second. That's too much, right? It's too much. What happened there? Am I correct? Yeah, I'm correct. 20 meter per square second. Yes. Then you can apply S equal ut plus half at squared for that time period. I mean the 5th second. Within that 1 second, I mean 4 seconds to 5 seconds time period, you can apply S equal ut plus half at squared. So you should find the initial velocity now. S equal ut plus half at squared. You should find the initial velocity within this 4 second to 5 second time period. So what is the distance? 90. Initial velocity of finding. What is the time taken? 1 second. Okay. These are 4 second to 5 second time period is 1 second. So that one don't ask me what is the time taken. So half into 20 into 1. So this one 10. U is going to be equal to 80 meter per second. Right? U is going to be equal to 80 meter per second. What are they asking now? They are asking what is the velocity at the end of the 5th second. Now we are applying V equal U plus AT for 4 second to 5 second time period. Now final velocity is going to be 0. right? No, 0. We are finding final velocity. Initial velocity is going to be 80 plus 20 into 1. So it's going to be 100 meter per second, right? 100 meter per second. Answer is answer number 4. Answer number 4. Then question number 15. The reaction time of a driver is 0.5 seconds. Nice. The reaction time of a driver is 0.5 seconds. After applying brakes, he can obtain a deceleration of 5 meters per second. When moving at a velocity of 20 meters per second to avoid an accident, at what distance from the accident should he apply the brake? Now, he sees a threat. What does he first do? What did he first see? The threat. My words are like jumbling today. I don't know why. First, he sees the threat. So he sees the threat, and then the nerve impulse will go to the brain and then to the body. So that is a reaction time period. I mean, to press the brake, you need a certain time. So within that 0.5 seconds, the car is moving actually. You can't press the brake without the reaction time. Reaction time should be consumed in order to apply the brake. You see the threat, reaction time takes place, and then you apply on the brakes. So within that 0.5 seconds, the car is actually moving. So you need to consider that. Then after that, what happens? After applying brakes, he can obtain a deceleration of 5 meters per second. Okay. Now the brakes are giving deceleration of 5 meters per second. So your answer should be distance traveled before pressing brake, right? Before pressing on brakes, AQA, like in the reaction time. Okay, reaction time, reacting time, 0.5 second time period. That one you need to find. Then after that, distance traveled after pressing on brakes, right? Distance traveled after pressing on brake. Now we should like consider the reaction time period 0.5 seconds. That one is moving with the same velocity. So S equal ut you can apply there. S equal ut. What is the velocity? Velocity is going to be 20 meter per second. 20 meter per second. 20 into 0.5. That's going to be 10 meters. So once the reaction, I mean 10 meters have gone. I mean actually when the signal goes to his brain and goes to his leg, within the time period 10 meters go. See how fast this car is going, right? So after that, to avoid an accident, what is the distance from the accident? Right. Okay. Then distance travel after pressing on the brake. Now you should apply a equation, right? B squared equal U squared plus 2A, something like that. You should apply. B squared equal U squared plus 2A. Okay, now he's applying on the brakes. This is the point which he apply on the brakes. So final velocity is going to be 0. He's going to stop. So initial velocity 20 meter per second. 20 squared minus 2 into what is the deceleration of 10? 5 meters per second. 5 into S. This is 5, okay? 5 and this is S. So 5 into 10. 10 is going to be equal to 20 into 20. So this one cancel off. S is going to be equal to 40 meters. S is going to be equal to 40 meters, right? So 40 plus 50, 40 plus 10, you need to take the addition of that. So it's going to be 50 meters. So if you had taken this one and put the answer as 40, you're wrong. If you had taken only this one and put the answer, you're wrong. You should take both of them and add it and get it. 50 meters, answer number 3. Then question number 16. That one interesting question. That one is going to be interesting, right? That one is going to be interesting. 16th question, I'll put it as hard one. Okay, 16th question, I'll put it as hard one. You need to understand the concept behind it. Not hard much, not much harder. Little bit harder actually. Medium, let's say medium. Right. You have two objects, train A and train B. This is A. This is B. They move towards each other. They move towards each other face to face, and they are going to get hit. Okay, they are going to get hit. They are going to face an accident now. Move towards each other in the same rate. When the distance between them is 1 kilometers. Okay, now I'll take the crashing point as this one. What did I do? I took a crashing point somewhere in the middle. Okay, so I'll tell this one is going to be x. Displacement from here to here is going to be x, and the distance from here to here is going to be 1000 minus x. So why 1000? 1 kilometer is equal to 1000 meters. So 1000 minus x. Then after that what? After that what? The deceleration obtained by train A is 1 meter per square second. A is equal to minus 1 meter per square second. Then we have to find this one actually. Acceleration of B. That only we are going to find. In order to avoid an accident, what is the minimum deceleration that should be there for train B in meter per square second? Now imagine like he presses on brakes but he doesn't. So they will hit each other. Both of them should apply brakes to stop this accident. So what is the minimum deceleration which he should get in order to stop this accident? I mean, like they should stop like touching each other like this. No accident, but touching each other. That is what we are going to find now. Right. What I will do is I'm going to apply what v squared equal u squared plus 2as I can apply. There is no time involved here, right? So you can apply v squared equal u squared plus 2as from this situation. Okay. For a I will apply. For a. So v square is going to be 0. Final velocities they are going to come to rest, right? They are going to come to rest. So v square is going to be 0. The initial velocity 20 square plus, not plus, minus. Why? Acceleration is minus deceleration. 2 into 1 into x. So you can find x directly. Okay, that's going to be easy. So 2, 1. 200 meters. X is going to be 200 meters. So 1000 minus x is going to be 800 meters. Now easy. So then you apply v squared equal u squared plus 2as. Then final velocity 0. Initial velocity 40 squared minus, not minus, let's put plus. Let's say we don't know. Then 2 into a into, we are finding a into how much? 800. So a is going to be equal to 40 into 40 divided by this minus. Then 2 into 800. 0, 0 cancels off, 0, 0 cancels off. 2, 2 is going to be 8. Right? It's going to be 8 meter per square second. Sorry, I didn't see this. This one 2 cancel off, this one 4, this one 1. Then other train also going to be 1 meter per square second. Other train is going to be also 1 meter per square second. Minus 1 meter per square second. Answer number 1. Answer number 1. Then 17th one. 17th one. An object which is following linear motion is moving 14 meters distance within 5 seconds. 5th second. Within the 5th second. Not 5 seconds. Within the 5th second. 4 to 5 seconds. 4 to 5. 4 to 5. 4 seconds to 5 seconds. 4 seconds to 5 seconds. He is going to move a distance of how much? 14 meters. So if I apply Sn is equal to u plus a over 2 into 2n minus 1, you can apply these equations only if you are doing MCQs, okay? In SI equations you can use this. Then 14, initial velocity you don't know, okay? I'll take it as u1 plus a over 2 into, why am I doing this now? What are they asking? An object which is following linear motion is moving 14 meter distance within 5 seconds and 20 meter distance within 8 seconds. What is the distance moved by the object within the 15th second? We need to write two equations and solve it. So initial velocity is going to be u. When starting, okay, we don't know that, so we are going to put it as u. 2 into 14 minus 1. I'll take it as, I'll solve this in 14 is equal to u plus 14a minus a over 2. Then, okay, 28a, 27a, u plus 27a divided by 2 is equal to 14. So 28 is equal to 2u plus 27a. I'll take it as equation number 1. So this maths part I don't need to explain you. You need to know that. Okay. This maths part. Is it recording? Yes. Okay. Right. Then next one they say 20-meter distance within 8 seconds. Then next one is n. Problem. What is this 5th second? Sorry, Ayo. 5th second. 2 into 5, 10 minus 1, 9 is going to be. Oh, miss. U plus a over 2 into this one. So 5a, 5a minus a over 2. So it's going to be 9a over 2. 9a over 2 like this. 2u plus 9. Am I correct? 4 to 5 is n equal u plus a over 2 into 2a minus 1. U is this one. Acceleration a over 2. 2 into 5 minus 1. This one will cancel off. Then 5a minus a over 2. And then you get the common denominator and then you subtract. Then you get an answer like this. So this is the first equation. So next one, Sn is equal to u plus a over 2 into 2n minus 1. So what is that? It has more 20-meter distance. 20-meter distance. Initial velocity u plus a over 2 into 2 into which second is that? 8th second. 2 into 8 minus 1. So it's going to be 20 is equal to u plus 8a minus a over 2. 20 is equal to u plus 16, 15a over 2. So 40 is equal to 2u plus 15a. This one equation number 2. Now what you're going to do? You're going to this one 9a. You're going to subtract 2 from 1. You're going to subtract 2 from 1. 2 minus 1. Why? You're going to find the initial velocity. 40 minus 28 is equal to 2u plus 15a minus 2u minus 9a. 2u cancel off. Then 12 is going to be equal to 6a. A is going to be how much? 2 meter per square second. A is going to be 2 meter per square second. Then I'll substitute to where? Where will I substitute? I'll substitute to here itself. 14 is going to be equal to u plus 2 over 2 is 1. Then 5 to 2, 10 minus 1, 9. So u is equal to 5 meters per second. Then what are they asking? What is the distance moved within the 15th second? So you use all this information you found to find the final answer. What? Sn equal u plus a over 2 into 2n minus 1. Initial velocity 5 plus a is going to be 2 over 2 and 2 into which second? Why am I forgetting? 15th second. What's the distance moved by the object in 15th second? 2 into 15 minus 1. 5 plus 29. Right? That's going to be 34. 34 meters. Answer number 2. Right. Good. 2 more questions remaining. 18 ton. A 150-meter long train entered into 300-meter long railway platform. Now draw the train. How the train is big like this. Okay, now the train initially positioned here. This is the platform. This is the platform. I draw this as the platform. Okay, this one as the platform. Okay, this one is the platform. This is the train. This is the train. That's the platform. What is this? Platform. And this one 300 meters. This one 150 meters. So train passing the platform means its backside should be here. Its backside should be here. So let's take a point at this backside. So backside should pass this 150 meters and this 300 meters to reach this position. So the train passes the platform means everything should pass away. Everything of the train should pass away out. So how to do this question now? 150 long meter train entered into 300 meter long railway pathway with 40 meter per second velocity. Okay, 40 meter per second velocity. The train passed the platform with 50 meter per second velocity. Here 50 meter per second. So it has accelerated. The acceleration of the train would be, okay, good. Now what I will do, you don't have time involved, so you apply this equation. V squared equal U squared plus 2AS. Final velocity 50 squared. Initial velocity 40 squared plus 2 into A into how many meters? 300 plus 150. Why? The backside should cross. So the backside should come 150, then 300. Then altogether 450. That is a tricky question. Okay, tricky question. Then what's the answer going to be? 15 to 50. No, we can't take that. 5 to 5, 25, 2500 minus 1600 is equal to what is this? 900, right? 900A. Then what is this? 900. A is going to be 900. A is going to be 1. Straight away answer number 3. Answer number 3. So if you take like that, if you take like 300 meters and solve this question, you are going to get 9 over 6. So 9 over 6 is 3 over 2, like you are getting 1.5. Okay. That one is wrong. The answer is answer number 3. Okay. What do they say? The train passed the platform. The train passed means the train has gone, not only the front side. The train passes the platform means, like, imagine if the train is inside the platform like this, the head is here, then the half of the train is inside. So that doesn't mean anything. So the backside should pass the train. Okay. So when the train enters here, from that point onwards, the train should disappear. For disappearing of the train, this backside should pass the train. Pass the platform. So you should consider total displacement 300 plus the distance of the train also 150, altogether 450. Then 19th question, easy. Okay. The velocity time graph of the object in linear motion is given below. The displacement of the object when the time is 20 seconds. The displacement they are asking when the time is 20 seconds. So you know area under the graph is representing the displacement. And the positive and the negative one cancel off there. Do not ask me why I have said this billion of time in the last 2 classes. Okay, this displacement time graph, velocity time graph, area under the graph, and negative velocities, positive velocities. Okay, last day class, last 5 questions I discussed, and that included this type of question. Okay, like displacements cancelling off in the top and bottom. So directly you can get an answer is answer number 2. Okay, answer number 2. And the 20th question is a repeat I said you, so leave that. So that's it. How many hours? 1 hour and how much? 1 hour and 4 minutes. Good. 1 hour and 4 minutes. So 18 questions actually. 2 questions we didn't do it. Right. So I hope you do this, and next week we are going to start what you call the Newton laws of motion and projectile motion. So that one separate question will be given, and another discussion video will be there next week for some questions like this. And we didn't do past papers. We didn't touch past papers still. Past papers will be also done. Okay. Right. Okay, that's all. I'll stop the video now. Make sure you rewind and watch if you didn't understand anything. And yeah, that's all. Bye bye.